They expect you to be able to do hard stuff well, be paying you $100,000 a year, right? Now, to be honest, there's a lot of jobs in the development side. It's very desperate for developers. They're willing to give a lot of people a try, even if you're not really producing doing hard stuff well. But fundamentally, one of the reasons that this is a hard major is that these are hard jobs, and people want to pay you well for those hard jobs, but you have to be able to do them, right? And I'd say one thing that's important is to be able to, you should add value and not subtract value from projects. In other words, it's still possible to be a team member and do such a terrible job that you make everyone else's lives harder. And your code is terrible, people fix it, you break things, that's one model, and there are people like that for sure that have development jobs. But we're hoping that at some point you are able to provide value to your employer or yourself, if you're self-employed. And that value is a big number. The market sets that at around $100,000 a year. And those are high expectations. So anyway, just kind of keep that in mind as you're going through your classes here, that people want something from you, and it's a pretty sophisticated thing they want. Right? That's why I brought that up. There's some difficulty and quality here that makes this a high-paying job. Any other comment on that? Some of you already see that your internship is getting paid $25, $35 an hour or something, right? And that's something where they're presumably sort of training you to be a useful person. That's still worth the equivalent of $50,000 to $75,000 a year if you're paid full time or full year kind of thing. That's a pretty big deal as well. So I mean, there's good things to look forward to, I guess is what I'm saying, but there are expectations on the other side of that as well. All right, Simon and Simon. What can I help you with? All right, well done.
My partner and I kind of used off during the break, so we have more time.
What's that?
My partner and I kind of used off during the break, so we have more time.
No, we're doing the next phase already.
What's kind of expected in terms of like the user's message? Like, is
Something mean.
So
Well, I said sort of the two main ideas. One is pop something up like a dialogue box, and the other one is just change like a background image or something like that. Anything that you can do that somehow gets the message across.
but I guess my main question is like, does that pop-up message, like, as a dialogue box, does it have to be like linked in with the UI itself, or like?
Meaning like does it dock inside the UI?
Yeah.
No. It'd be like normal dialogue pops in house.
Is it fun if it just like does like a repeated like flash or something like that to like indicate that?
As long as at some point you can flash and stop.
Okay, okay.
But that's cool. That's like the easy part. It's the end game thing, right? The other parts are hard.
So the single shot callback from the timer, do you know if there is it possible for a race condition to happen between that and a button press, or are they like kind of?
I don't exactly know how they get scheduled, you know.
Do we have to worry about that?
No, your button should be disabled while you're setting a single shot to play. You know, the playback should be different from the user pressing the button.
Okay.
But basically, you don't have to worry about it. But it should be, you have to disable stuff when the computer's just playing it.
We need a timer that you lose when the timer goes off. I don't worry that.
So you're making people answer in a certain amount of times?
Yeah.
That's not part of the normal game. But, and I don't quite know. That sounds fine in some ways. I don't know what the ramifications are of that. But
I just don't understand.
yeah. Anything else? Come on. I know. You have a suggestion?
Don't use a single shot. Make a connection for it, then you can stop it basically. So like he's using single shot, so he's setting up like if you don't answer in a certain time. But if you don't have it as a single shot, then you can kind of like do more with it.
You still need to end it sometimes if you have a time limit on your time.
Something you can like have something trigger that.
Right. Okay.
How fast do you expect it to speed up as moves go along?
Hopefully not too much.
I used a function that starts at like 100 milliseconds, and around 20 it reaches 200 milliseconds, and then it has an asymptote
starts at 1,000. Starts at 1,000, you mean? Or?
It starts at 1,000.
Okay.
After 20 moves, it reaches about 200 milliseconds.
Yeah, that seems pretty fast.
And
But
then it has a horizontal asymptote at 100 milliseconds.
yeah, definitely don't like divide by the number of moves or something like that. So then it goes from 1,000 to 500 to 300 to down to like 10 milliseconds or something. I think flattening off or just,
asymptotes at 100 milliseconds.
yeah, that sounds fine. Something that doesn't, I mean, you can kind of either just subtract a small amount, or you can kind of have something that flattens out, but don't make it get like faster, you know, so fast, like the 10 moves, if it's just like, that's probably too fast, right? Okay, so saying you guys sound files in the build folder. So we have our project folder with the .cpp's, .h stuff, and then you have a build, and the build gets the .o's, gets the executable, and you added some some sound file there, right? The problem is this build folder, you have no control over it. If I change my kit, then a different build folder is created. And I have to hand move over this file here. Put it in here. So you can still get to it. So the problem is when you run the executable, it runs from this folder, and there's some path that is down in this build folder. If you want to find something in here, you got to go up, and then down into the project folder and find the file there. So you should be able to load it that way. All right? And I sort of did that some other time with something. I don't remember what, but I went up and then back down again. I don't know what you call it over there, but that was the reason I did that funny thing. While you're having trouble with your connect calls, and it just seems like every time it's been some minor thing, like you didn't make it an official slot, or you spelled it wrong, or there's always something. So just because you basically don't get a lot of info on it, it says no matching call to this kind of thing here. There's something that's wrong. You gotta just look at everything really carefully. It's hard to find sometimes.
Just to clarify, all the connections have to be made within your window that should have some model parameters.
It should be made in the constructor, and I'm saying for the view. It could be somewhere else, but it's in one well-defined spot, and the spot I'm saying we should do it in is the view constructor. So you should pass in a model to the view constructor, use that in making the connections, and then hopefully don't store that model anywhere else.
What's the bare minimum extra feature?
The bare minimum is something that makes them say, oh, that's nice. I'm a weird natured person, you know.
So like an image of like a puppy, like
That's probably a weird loophole that would work. I mean, that's procedure, right? So it should have some logic to it. It doesn't have to be a huge long thing. Something with an if statement or some extra use of some QT thing that we haven't talked about yet. You investigate it on your own. Third button is probably not.
What about the ability to select how many buttons there are?
So dynamic number of buttons, that sounds very complicated. If you want to do it, go for it.
I already did.
Then the answer is no. Find something else.
I have a question like, which kind of is more broader. Because the user interfaces are so hard to test, like, how are you guys testing them? How are they deciding?
So testing of user interface is a whole subtopic, right? For us, it means we run the stupid thing, and we watch your little messages and say, here's how you play the game, hit next, and the cutscene you have of yourself being a cool silent guy, and all that stuff. But there are tools like Selenium that allow you to automatically click buttons on a user interface, and you can make sort of unit-like tests that say, if I click this and then this, what happens? So there are automated ways of at least getting some behavior like that. But it's a lot harder than just writing 2 lines of stuff code. The other big lesson, of course, from all this is that if you call single shot, this is just kind of a made up thing. If I have this, what's the behavior of this? I execute these 2 lines of code. Let's see if I can do it.
So it'll wait 1 second and then call blue, and then it'll wait another second and call red, right?
That is not what happens. So that's where a lot of people are getting here.
So they get called pretty much simultaneously.
So this schedules when this gets emitted. And so there's some timeline. 0, it says at 100,000, schedule blue. And then probably at 100,000 in like 1 microsecond or something, whatever time it takes to go to the next command here, it schedules red. And they both flash at the same time. This is not a schedule and wait. It doesn't wait till that actually happens. It just says schedule this 1,000 milliseconds in the future, schedule this one 1,000 milliseconds in the future. All right? So if all your buttons are flashing at once, you'll probably just have some loop where you're saying something like single shot move 1, single shot move 2, single shot move 3, and they're all scheduled for exactly the same time. You understand? We're just scheduling something here. And then it goes on immediately to the next statement. Questions about that? So if you wanted this one to go at second 1, this one to go at second 2, what could you do?
You could like add some int after both of them, or increase that.
Change that number. Either mathematically or however you want to do it, right?
Like if you want them to be like faster off of some function.
So that would make it go like this, and then this could be whatever thing you want to do to generate that number, some function that knows how fast it goes and all that kind of stuff, right? So that's one possibility. The other possibility is to do something like this. Schedule a flash, and then schedule a second from now, call this again and do the next flash. Right? So you use that mechanism. There's sort of 2 main ways to do it. Either change the delay or just sort of make sure you don't move as fast as possible, once per second or something like that.
Right? Right if you single shot at all, you just establish your connection, and that automatically, basically, the queue timer has like, the queue timer.
Okay, so the queue timer emits signals at a set rate.
Exactly.
And so if you do that, then you basically go through your flashes all exactly. And then somehow you kill that thing when you're done with it, right? Right. That's another way to do it. All right, so those are the main things I'm seeing. Anything else you think of that needs to be clarified? Nothing? All right. Can we like take the murmur down a little bit here? All the little side conversations. If you really need to go talk about something, you can go. So that's talking to you guys. Talking back here. A lot of noise, okay? Thank you. Yeah, moving on. Okay. So waterfall is planning time. The goals. Once you're done with planning, the implementation should be straightforward. A goal of this approach was that the coders can then be kind of low quality, not pay them 100,000, pay them 30,000, just do some sort of syntactical conversion, and all kind of comes out. Business likes that, of course. Programmers do not really like it. So you don't want to be fed pages of specification and you just say, for loop, blah 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 blah. So that was not a particularly successful outcome of waterfall planning. In waterfall, we start with these requirements. We have, not much idea that they actually do it, but some idea that basically there's some sort of document that says what the project should do and the functionality of all the subpieces, right? And there's some patterns you can follow, some templates. Yeah.
So I'm confused why it says for the waterfall, low quality software.
Well, if you have a lot of planning, you can really describe very carefully what everything is supposed to do and sort of, how it does it, then at some point the implementation supposedly gets easy. That was the thought.
Oh, okay.
You're breaking it down to little small pieces. And it's back to this model, you have a big project, and you slip under everyone's door on a little sheet of paper saying, write this function, you write your function, you put all the functions together, and it all magically works, right? Which is not really how reality works, but that was the hope in some ways. All right, at some point you want to design the system. And how do we do that? How do you communicate a design? And it's still a hard thing, I think. There's a lot of different design methodologies. So in the 90s, a lot of people were pitching different approaches for this. The Booch method, object modeling technology, object-oriented process. And they all involve these sort of diagrams of like, here's a class, and they relate to each other in various ways, with arrows and stuff like that. But you would kind of sketch out by yourself, except in this case, they have this horrible, you know, I think it's supposed to represent sort of an abstract kind of thing, right? It's not, anyway, I don't like it, but someone liked it enough to be famous for it. So, but these kind of diagrams kind of show how the parts of the system relate to each other. Then, so the mid-90s, so a lot of these competing approaches were combined together. This is also a very awkward picture here, distilling their ideas into this one thing called UML, Unified Modeling Language. And that's sort of the main standard right now for how these design sort of documents are produced. Of course, there's some issues with that situation. There are 14 competing standards. 14, ridiculous. We need to develop one universal standard that covers everyone's use cases. Yeah. Soon situation, there are 15 competing standards, right? So it's easy to say we need something that works for everybody, and typically they just add to the mix of standards. So this UML is controlled by the Open Modeling Group. You can go to their website. There's different versions that came out, UML 1, UML 2. The current release, mercifully, is still in 2 and last ratified in 2017. So anyway, there's people that are sort of guiding how these diagrams are constructed. So UML, of course, is supposed to be sort of a language and platform independent way of describing software architecture. So you're already kind of like, you know, you're not going to be getting into the nitty-gritty details here. It's going to be some sort of vague overview of how these things are related. There's already, I would say, strong object-oriented emphasis in how they do it. There's a lot of stuff in class diagrams and so on. I don't really know, for example, if you have a functional programming language, what that looks like in a UML diagram, like how exactly that works. So you use these diagrams to show the connections between different subsets of the project. And there's different ways of viewing the system. They have a whole bunch of different views that, you know, are like, well, we'll get something. So UML in the real world, I would say this is one of these things that a lot of people don't like. They just think it's a waste of time, right? So there's a nice Stack Overflow discussion on this. Is it practical? There are many enterprises who swear by them and many who outright reject them as an utter waste of time and effort. So some groups like them, some don't. Most people would love to get 5 to 10 pages of simple class diagrams and some basic description of how the system is put together. So in a big system, yes, it is nice to have some sort of overview of how the system is organized. And if you're going to do that, you may as well use something that has some standard to it, like UML. Using UML is like looking at your feet as you walk. It's making conscious and explicit something you usually do unconsciously. Beginners need to think carefully what they're doing, but a professional programmer already knows what they're doing. So they're saying, you know, experienced people have no need to sort of plan this out in advance. UML is used all over the place. Anywhere an IT project is being designed, UML will usually be there so that someone who thinks it's pervasive. The way I view UML and this other process is that it's more talking about what you're going to do than actually doing what you're going to do. So like most planning people with things, people want to get code going and they don't want to plan. Every time I diagram something, I save myself hours or months of development time, and I almost always develop alone. So you're someone even not working in a group that still finds it useful to go through the process of doing an explicit design, and they think it makes themselves a lot more productive, which if you're developing alone probably means you're billing a lot more valuable time. And then I think the 2.0 spec has made what was once a clear specification somewhat bloated and cumbersome. So I would say that's probably a little true. UML started off with pretty basic ideas and just kept adding stuff to it, and now it is kind of just a big old blobby mess that can totally handle everything but doesn't really do anything that well, in my opinion. All right, so I would guess at some point in your professional life, you're going to run into some kind of UML type thing, and it's good to be exposed to this a little bit. So there's some studies on this, UML in practice, 2013, interviewed 50 developers, not too many really, 35, no UML. 11 had some selective use of UML. 3 of them actually generated code from the UML diagram. So there are tools that will say, hey, you made this design, and then like generate the class code automatically. And there's a whole bunch of these different kind of diagrams they have, and there's a few of them that you use more than others. So, that's not too impressive, 20%, 22% using UML. My guess is, again, there's probably a lot more people, they're doing some sort of UML-like activity. Maybe they're never trained in the specifics of it, where you're drawing something, talking to your coworkers, and drawing on the board some kind of boxes with arrows between them. And so, I think that's probably underrepresenting sort of usefulness of this sort of design kind of a process. And there's probably some benefit to sort of doing it right instead of just sort of always sketching something. Any of you who interned or are working right now, anyone using UML? Where is this?
I interned at NASA Jet Propulsion Laboratory.
Where?
NASA Jet Propulsion Laboratory.
Okay. And what did they do with UML?
We had to do UML before you started working on your project to see if it was still relevant.
And what kind of UML did you do? Like a class diagram or something? So some sort of diagrams like that? All right. So the government probably likes this kind of bureaucratic process a little bit. Anyone else?
In the security department at Workfront, we had to create UML diagrams to better threat model and attack vectors on the project.
And was that some sort of, not a class diagram, but more of a use diagram or something like that, Yeah. Okay, so there's security people that are also kind of serious about what they do, right? Probably want something like that. So, anyone else? Good. All right, well, let's see. A little unscientific survey, I guess, but still something. So again, given a model of a system, there's all these views of the model. And there's like state diagrams, talk about how you kind of flow through the different processes of your project. Sequence diagrams also give kind of a time flow, how you interact with it. Use case is basically all the different reasons for interacting with the software. And then really one of the big ones are like the class diagrams, what most people are sort of familiar with. That's what we're going to just talk about now, the class diagrams. You can tell there's already like all this stuff here, right? Like you say UML, again, it's not really unified, it's a big blob of stuff. So, I'm not going to use this today. Class diagrams help you think about the architecture of the system. And it's basically, you're thinking about, is there information that has to be stored? Are there services on those data that need to be done? And one question is how you sort of begin. So you have some sort of project, and how do you even start thinking about like the classes that you use? So let's say I give you some problem. The problem is like, with assignment game, you said, make a view class, make a model class. You didn't have to think about how they get split up, right? And so a lot of your assignments are like that. Even Haru was like, make a wrapper class, make a spiral class. And you're not like just given a problem and thinking about, where do I begin? How do you, let's say you don't have a specification for assignment, you're working on some project. How do you decide what turns into a class, for example? How do you, you split into 2 classes? Is there something that goes on in your mind, I guess, or you not run into the situation here? Yeah.
Well, oftentimes it depends on the scale of the project and how it integrates. Like where I work, I'm only usually doing something pretty small, so they don't want me to have 2 classes to put into the DLLs.
So you guys sort of 1 class at a time, so given a problem, sort of class size to begin with in some sense, and you kind of work on it, or you change another class or something like that, right? So anyway, this is a hard, sometimes you develop and you start saying like, all right, these 2 things no longer seem to be like one thing, they're like 2 different activities going on, and you split it in half or something, you can sort of incremental stuff. But if you're doing it in advance, you need some ways, some tools to kind of make this happen, right? So here's a system, elevator system. The elevator must close its door before it moves from another floor of the building. And this could be, software, so, a virtual elevator and all this. And somehow you need to decide how to represent this how to architect this system. So one way is, for example, instead of concentrating on the verbs, close, store, it moves, it kind of tells you the things that happen to the data in some sense, right? That's sort of a procedural or functional view of what's going on. With object-oriented programming, a lot of times you want to go and look at the nouns involved. So let's see, how do we do this again? So there's like the elevator, and there's the door, and there's a floor, and there's a building. So you look at the nouns. Those are sort of candidates to be objects, right? And maybe you want to say, okay, some of these objects don't actually have services, they're just data. So for example, until we know more about the floor might just be a part of a building or something like that. We don't have any like services it does, it just sort of exists. Even the building maybe just sort of exists. But things that seem to be doing more stuff, like elevator opens and closes its door and moves between levels, maybe sounds like a better candidate for being a class, right? There's some data involved, like the elevator, and what floor it's on, and stuff like that. And there's some actions, some services that we need to implement. And so, that's, it sounds a little silly, but there are people then, that's how they start with some project description, and they just sort of look at all the nouns, and then kind of think about, are these things I want to represent in a more complete way or more formal way? And then you start thinking about how those things would interact with each other a little bit. So nothing too exciting there, but this gives you a start. If you're just like, I don't know where to begin. That's some place to begin, right? And give that a try. All right. So in UML, there are these class diagrams, and it's kind of weird because they're like we are language independent, but they basically just make up their own syntax that reflects like all the other languages that have these common properties in some sense. So the typical box has three parts. There's the name of the class, essentially. There are the data members of the class, and then there's the methods of the class. And so that already looks an awful lot like, every Java and C++, and to say it's independent of those is just a little bit, off in my view. Then, just so they don't pretend to be Java or C++, they have access modifiers. You can use minus for private, and public is a plus, and then protected is a hash mark. And so again, just by coincidence, there's like a one-to-one correspondence between these things and the languages that we know and love, basically. And then down here are the methods, and you can sometimes you can annotate these with some kind of type information if it seems important, like this is a string, this is an int. And maybe you want to be vague about some things, it doesn't really matter that much. Same kind of thing here. Here's a method. It returns a string, and get monthly pay also not specifying in this particular case. So some stuff you can kind of leave unspecified, some stuff you actually specify. To me, this looks like, this goes back to that Brooks quote where he said, anything that tries to hide the fundamental complexities of software misses the nuances of it. And here they are not hiding the complexity. They're making you do all, this completely exactly matches a .h file in some sense. But it doesn't make any, to me, it's not like a better way than an H file. I'm just as happy to look at a header file as that thing. But, again, less formal, so maybe you're more willing to change it around and experiment before you can decode. There are tools that will take these things, and then you can say, make me a Ruby class, make me a C++ class, make me a Java class from this. So again, it seems like this sort of powerful idea. But the question is whether this fully captures all the details of those kinds of languages. So if you can't get all your static in there and your other things, you're kind of limited in what you can do. But again, businesses like the idea that they can have some designer design a bunch of stuff, they hit a button, and like 1,000 classes all spit out, all ready to compile and do things. So anyway, there are these things. Now, it's one thing to build a class. In architecting a system, you're really more interested in the relationship between these different classes. And so we have diagrams that capture that, and they're nothing too unusual sounding. For example, we use an arrow to show that this is a subclass of this superclass, basically, right? And commonly, the base class is on top and the derived class is below. But this is exactly what we would draw by ourselves, essentially, if we wanted to show that this is, we're just sketching on a board what these things look like. So employee inherits from person in this particular case. So that seems fine, but they just can't kind of leave well enough alone. And so they add a whole bunch of other arrow types into the model. So there's an association arrow. And I think this one's this basically says any kind of relationship between classes that they're connected somehow is, by at the most general form, an association. So for example, a player of a game might take a turn that uses a dice class. And so we're going to show that these two are related, right? And this player thing needs this dice class to function to be out. So there's this sort of uses idea here. And you can show some sort of like, it uses a bunch of these things, you have a little number on there, 1 to 6 die, depending on what kind of game you're playing. Then there's something called aggregation. And aggregation means that this thing has some of these. So it's sort of composition in some sense, right? But aggregation means that the wheel has an independent life cycle from a car. So you can take a wheel off a car and, trade it in or sell it or buy a new wheel. And it's not like the wheel, if you get rid of the car, it's not like the wheel magically, vaporizes, right? They're independent kind of things. But a car has some wheels, and so these two are related, and they're related by aggregation. I do not like this style here because I like arrows that start with a line and end with something, and this goes to this, and instead it goes sort of the opposite way. This is like where it starts, and this is where it ends, right? I always get this backwards because I just kind of think this as sort of like the same as the head of an arrow, but it's the base of this kind of line. So anyway, I'm always wrong about that. I have to look at it. So this open diamond here means this thing has some of these but doesn't control it. Actual composition in their lingo means that you do control it. So for example, a person has a head, and if you get rid of the person, the head dies too, right? Unless it's like Futurama, I guess. Or something. So in this case, the person controls the life cycle of this thing here. And you fill in this diamond shape thing that happens.
So is that like saying that it inherits from the person?
No, it is saying that a person has a data member that's a head, and if you construct a person with a head, that the person is responsible for deleting the head when the person also gets deleted. Okay, so it controls the life cycle of this thing here. And notice also in these last two examples, we weren't really going up and down with it like we would in inheritance. We're going side to side to show more of a relationship, not a dependency.
So like the previous one was the open diamond, that's kind of how we're using like now with our model where we're not necessarily controlling that model, we're just part of.
So like we have a view here, and we have a model over here. I guess right.
Like we're using bits in it, but we're not necessarily controlling.
Well, actually, I would say that typically this relationship means that you do have a data member that is this thing over here, and you don't have a data member of a model in the view. You use them in the constructor. So I think our model view relationship would actually be an association. Right? They're connected like that. So if it's just somehow in the code, it's an association, like a parameter type, or you're spitting it out as an answer or something like that. If it's a data member, there's two choices for that data member. One is that you don't control the life cycle of it, and one is that you do control the life cycle. Okay. But the hard thing for me is this arrow thing going what looks like opposite directions. All right, other questions about that? So typically the containing thing is on the left and the thing it contains is on the right, and then inheritance, the superclass is above, the subclass is below. And if you're doing this, in design with particular kind of language, you use like, camel case for C++ and underscore style for Python kind of thing. You just match whatever language you're aiming at. If you want to, you can say that there's some sort of preset kind of objects in the system that are, are going to exist no matter what. And so you can kind of give a named instance of a customer, me, and the name's no longer general, it has a specific value, and apparently I like cheese sandwiches, and so that's, I don't know why that's important, but it apparently is. So. All right, let's look at some tools for this. And there's a bunch, if you Google UML tools, there's a bunch of stuff. And most of them, unfortunately, are for pay. So it's not like they don't have a good student, try them out programs for themselves. Sometimes you do, but you only have 3 people on a team or something like that. But there are different ways of generating these things. So one is called a UML lit, that is an app, and then they have an online version called Umlatino. Actually, I'm not sure exactly how one says that first, but it's a free tool. And it has a bunch of different kinds of UML diagrams. So you can have this class kind of thing, but for example, you can also have an activity one that has its own set of things, and it has a use case, which has the use case is the one that really offends me, these ugly stick figures. But whatever. All right, so our class, and I typically just start with a simple class, and well, I supposed to do it for something somehow. And in order to kind of specify, you have to learn their little language. So this is the name of the class, person. And then you use 2 dashes to make a line across there. So it's just like a markup language kind of deal. And then I'm going to have a private name that's a string. And then dashes make the next one. I'm going to have a public get name that returns a string. All right, so I just made a class diagram of a person here with data member and if to learn how to make these different annotations, at least in this particular case, I like to go to this very complicated looking one that has everything in it and look at its properties. So it has the dash here and those kinds of things. So basically, you can kind of just follow along my example. I'll have you, a nice little thing that says, I don't have a little cheat sheet anywhere that says how to make these things. So you have to kind of follow along as well. I think there was this big one. So I can make another class, and I'll make this a student. And I don't have anything else to put in there for now, so let's do this. That's not what we're saying. We want to say that student inherits from person, so we're going to grab this thing here and put the base here. Oops. And let it go here. All right. That could be straight. And that's basically how you build these things up. And there's not really too much more than that. The only hard part in some ways is then deciding what things are connected to association or composition or inheritance or what. And I would also say sometimes it's fine just to say, I know there's a student I want to have as a class. I'm not going to say exactly what's in it yet, so we kind of work out the details a little bit more. Or maybe I'm going to use some external library thing, and I'm not going to list all the data members in that external library class because I'm not developing it, I don't care about it, I just want to use it. So just make a box that has a name or something like that. And you get to sort of pick and choose what seems like the right level of detail on these things to represent your ideas of how these things are constructed. Okay, so that's a tool that does this stuff. there's a lot of different ones. I mean, some people just use PowerPoint to make these things, and then they little boxes and arrows and stuff, and fill them out. And again, there are tools that then take these diagrams, and if you fill out all the details, it then generates like some sort of C++ class code for you. Again, whether that seems like an easier way to develop C++ than actually developing C++ is your own opinion, I guess. Here's a bunch of different ones. Again, the one I'm sort of picked on is this Latino. Surprisingly, even like Emacs, which is a text-only editor, you can take, it has some packages. You can take like your header file, and it will generate UML diagrams in like ASCII text kind of box form for it. So anyway, if you're into that kind of stuff, that's a fun thing for try. And then there's like very expensive tools as well that probably help with a little better than the free online one, but I can't tell what else I'm going to do with it, so I don't want to really look for it. All right, basic idea, okay? Questions?
I was just going to say like another, aside from that, I use draw.io and they have a lot of good templates.
Oh yeah, I think
It like automatically makes orders and things.
I've run across that one too. It can handle a whole bunch of different kinds of diagrams. It's a nice thing tool. So, okay, so all right, so that's enough of that for now. We'll probably do one more kind of UML diagram, but to be honest, I'm not that into it, so I'm not, I don't want to talk about it forever. So next Tuesday, remember, let's do that. Next Tuesday we have a quiz, and it's on some inheritance stuff and QT stuff. So let's just do a quick review. And okay, we have class A, what's this stuff? Class B, inherits from A. How do I set up the B constructor? Talk to your neighbor about this briefly. All right, what do I need to do? So we're making B. Here's the B constructor. Somehow A needs to get set up, the part it inherits from. How do I do it in C++? Where's the colon go?
Right after the
Okay, we're halfway there. 2/3 of the way there. All right. We call the constructor in the initializer. Right? In this particular case, the A constructor doesn't take any parameters, so we don't have to put anything inside there, and it automatically sets X to 1. So we say when we're constructing B, first make the A part, and then do whatever you need to do for B, which in this case is the name you need to do with what's on data.
I can't remember. You have to do it. You can't do it in the code block. Is that correct?
You can't do it down here, because you can never really call a constructor directly like that.
Oh, okay. Okay.
Right? So, up here. All right, pretty easy. All right, a very general, possibly essay-length question that you might want to ask and read. How does polymorphism work in C++? No, I don't know what that means exactly, but to you, what are the important parts of how you do polymorphic behavior in C++? Maybe we can help and say there's an A mark, and there's a B that comes from A. My notation's getting bad here. That also has bark. How do we make polymorphic behaviors work in C++? First of all, when I say polymorphic behavior, what is the desired outcome from this polymorphic behavior? What does that even mean? Like, what does it mean to ask, I wanted to generate something that acts in a polymorphic way?
That upon execution, due to runtime decisions, the proper method for the subclass would be called for the parent class, depending on if it's specified in the subclass.
Yeah, somehow we want this thing to fire instead of this thing at some time, right? We want to, and then there's a C class that also comes from a, I don't know what I'm trying to do here. And if it's a C thing, we want to pick bark for this. If it's a B thing, we want to bark for that, right? That's what we're going to polymorph. So what syntactical things do we need in C++ to make this kind of thing happen? Okay, so first of all, if I just call my B dot bark, it's just going to bark for the B class, right? I mean, there's nothing here to worry about. That's not polymorphic behavior. That's just calling bark on B. So what does it mean that I need to do to, what else do I need to actually make this kind of thing where there's some decision being made, right?
You have to set bark in a virtual.
Okay, so but let's go the other direction first and see why we need the virtual. So if I'm just calling here again, I don't care if A exists or not in some sense. I've overridden it, and I'm going to call bark. So why is this a problem?
C++ goes to the most parent of bark.
Okay, so there has to be a parent some, but that's not. If I just say I have a B obj, and I say B obj dot bark, it actually calls bark here no matter what, even if it's in parent.
I thought C++ started as a parent, and you have to set it.
Only under certain circumstances. And what are those circumstances?
If you have like a pointer to a B object, and you use that, it should go to the bark.
If I have a pointer to an A object, and this thing is a new B object, so I'm storing an actual object under an A pointer. And in this case, this bark would go to the parent because it thinks it's an A type of object. All right. Now again, this comes up, not that we're ever like weirdly and dumbly saying I'm making a B object, let's store an A pointer for kicks, right? Where does this come up? Like, why do we do this? Why do we store B things in A pointers?
If you got an array of both B and C objects, you just the array A.
Yeah, typically if this is some collection of things, and I want to store a bunch of B things and C things all under this A pointer, and make it decide which thing they are when I run it, that's where this comes up. It also comes up again in, kind of like in Java, when you make a parameter of a method be the base class, so it's the most general thing available, and you can send it different kinds of sub-objects and do whatever you're supposed to do with your column. But one place we see is that so we have a collection of A pointers, collection of B's and C's. We want to loop through it and say bark on each one of those things. And if the B thing, it should bark its way. If it's a C thing, it should bark its way. Right? I guess they're all barking. I don't know. They should be talking. One part is one house or something.
Where it says new B object right there, is that supposed to be a new B?
Yeah.
Okay.
My syntax. This is more of a UML diagram than C++. Right? Okay, so make a new B, store it in an A pointer. If I did that, this thing is going to bark. But we want this thing to bark instead. So how do we do that? This is what you already told me the answer at this point. We say this is virtual. And we're optionally allowed to say that this is virtual as well, to sort of reflect that. And that means wait until your runtime, query the object for what its actual method is, to be bark, and use that instead of the A bark. All right, so again, it gets a little more explicit in C++ to get the polymorphic behavior. Java, we did this thing, it would always, and you sorted it in an A reference, it would always be the B barking no matter what you do. And in this case, you have to tell it, I want to actually get this polymorph behavior by hitting the virtual.
If the virtual is on there, it still allows a B object to directly call it stuff.
So this only matters when it's a pointer or a reference on a base class storing a thing that is a subclass. So even with virtual, if I had my B obj, and I said B obj mark, that's still that one's one mark. Which wait, that's what's gonna happen anyway, right? Is that what you're asking now?
Yeah, like if you make the virtual, it doesn't change that.
Right.
And just make sure that the pointer goes to the most child level.
Yeah. Yeah. If I make an A object and say A bark, it barks.
I was just wondering if it doesn't, like, making sure it doesn't change that.
Yeah. All right, so the key is you have to store a pointer or a reference to a base class and have it hold a object that is a subclass. And then when you see virtual, it calls the lower level one there. So I want to ask a question.
You had a C object that inherited from B, and you didn't have virtual in B.
Once you can kind of contaminate it, it goes all the way down to
What would happen if you wanted to call the bark from A on B object? How do you do that?
Okay, so how do I get bark out of this case here? Okay, so we have a B object stored in an A pointer, and from the B object, I give it a scope. So I want the A version instead. I think that's right. I don't do it very often for sure. So, but that's weird, right? You can kind of say I want the A class version there.
So if we omitted the virtual in the B class, would it still work, or is that?
Yeah, this is optional.
So
I like it so you have some idea that it's coming.
So it's kind of like the override.
A little bit like override.
Right, you're overriding it, it's kind of letting you know.
It doesn't actually enforce it though, like override Java does. It doesn't spit an error out if you're not doing it.
So on that, like, kind of, like I said, that contaminates the rest of it. If you have like A to B and then B to C and C to B and you wrote the virtual at B, is that where it starts?
I don't know anymore. Yeah. I don't know. Okay, so I think some things to keep in mind. You have to be a little more deliberate about it in C++, to enjoy the fruitful benefits of polymorphism. All right. And then part of it also is going to be some of this Qt signal slot stuff. You know, recognize what a connect looks like, understanding the timers, so they don't all go up at the same time, kind of stuff. I'm expecting you to get that from your assignment. Let's talk about the next assignment. We're going to make a sprite editor. A sprite editor is something that makes sprites, and sprites are those little 2D like images in games that move around the screen, right? Sometimes they're not like a static image; they like are animated, right? So they. An example sprite editor is this one. So you have some frames. So you loop through some number of frames as the game goes, and the character has a little animation. And you have different sizes. So for example, I can make painful. I'm an artist. So we have a zoomed in view. We have like an actual size view here. And we have these frames. I'm not sure exactly why they're like so different here. And then I can make it like a new frame where I could. A lot of times when you want to, animation, you want to kind of build off the last frame, so you duplicate the frame, and then I can. Oops, wait, not there. Over here. So then somehow that's not very good. So you can see, it's like a live preview of what the animation looks like. And you have number of frames over here, you can delete frames and stuff, different tools, typical drawing kinds of tools. You can set sizes in here, you can export different formats and so on. But the basic thing is, you know, it's easy to make, like you kind of want to play this game already, don't you? So, okay, so this is the goal of this project. It's going to be a Qt project. And you're gonna have, you know, it's not actually not all these drawing tools, you don't have all these things in here. You need something to basically let you mess with the pixels, either by clicking on one at a time, or you know, some kind of basics like that. We're going to do this using the waterfall method, which means we're going to have a week of planning and writing some requirements, and then a week and a half, a little bit more of implementation. Right, so you need to make a group, and there is a Google Doc I posted in the assignment document that lets you make an awesome team name. That's like worth half the points of the assignment right there. List the participants, and the thing is, you need to be able to meet together at some time, all right? I am going to give some time, like in the last 20, 30 minutes of class from now on, to let you meet with your groups, get some stuff done. But, like once a week, there's at least some time with like a TA, you need to go through some worksheet kind of stuff and show some progress. And so, you go to a lab session. It doesn't have to be the one you're registered for, but one that your team can attend. And then, if none of those work, you can petition, but you have to ask me and say, I want to go during some TA help hours, and this is the time we're going to go. I don't want that to be the default, where you're just going to be like, I'm going to go to help hours and do it, right? You have to sort of show me that you can't make any other time, like even at 8:30 lab. Your question on that? Or?
Yeah, how many people per team?
I'm trying to remember how consistent everywhere that I said this. So is it 5 or 6? I can't remember how many times I said 4 or 6, but is it 5 or 6 still? Okay, yeah. Pretty big group, right? But part of this again is that it's very different working in a group, some numbers rather than a pair. And somehow you have to get some experience doing that. At some point, there's going to be some team evaluation forums about what losers your teammates are. Because every year there's people that just really try not to do anything for their team. And we have to provide some appropriate evaluation based on that. And so for example, it's not though that if your team doesn't like you and the team all says mean things about you, we're going to look into it a little bit and we're trying to figure out whether you participated or not. But if you don't participate, you don't get credit for the assignment, basically, right? We're going to penalize you sometime. And it's pretty rare, but every year there's 1 or 2 teams that have someone that just like is just not part of it at all. So the first phase is going to be a market research document. So there are other sprite editors out there. Fiscal, use Google that to find some. And I want each team member to kind of look into one of them and say, hey, here's kind of what they do. Just a paragraph, a few features that you think are interesting. They all have the same basics, but maybe one that says, oh, I like how you use transparency to show this, or I like this, or I like this. So just I want you to go around and kind of investigate, help you brainstorm what you do in your own way. Then there's a software requirements doc. There's a template in the assignment that basically you should fill out, some parts of it that seem relevant and say, there's a paintbrush button that you click and it changes the tool to let's draw on the screen or something like that. There's a UML class diagram. So basically, make it 1 page, but kind of like crowded 1 page in some sense. Like you need to zoom in to kind of see it. But it should say, here's, for example, an image class or something like that, right? And we know we're going to use that in some way. And here is a toolbar thing. And they can have different levels of detail. Just sort of rough, again, don't list all the data members of them and stuff like that. But some things have a little more detail, some don't. And you can use a Latino if you want, or you can find some other tool if you want. This at some point needs to be a PDF that comes out of this thing. You should retain this idea of a view model, but to be honest, it's going to be a real pain to send signals. Every time you click on a pixel in the view to send it to a model, do a signal, and try to get an answer back. So, you have a model, but they can be a little more intertwined than we're doing with the assignment game. Don't worry about that as much. You need a Gantt chart of activities. So a Gantt chart is one of those things that says, here's a thing, and it's going to go from day 1 through day 5, and it's going to be the market research thing, and here's the people involved in it. And then there's going to be the requirements document, and here's the people involved with that. And it's from day 4 to day 6 or something like that. I give a link in the assignment. Go look it up, see an example. Just make a little chart that sort of shows what you think the breakdown of the implementation phase is going to be, right? The Gantt chart's not about what you did to plan this thing. It's going to be more like, we are ready to start implementing. Here's how the different activities are going to be laid out. Okay, so those are the main things. Here's the overall timeline. So here we are today. And you got a little writing to do, make some diagrams, plan it out. The thing is about the requirements document, again, the waterfall method wants you to kind of be sort of fixed in what you plan, and you have to implement it. So your plan has to be good enough to actually make a product from it, right? It can't just be like, we're going to make a sprite editor and you can draw on it, right? That's not enough. There has to be some list of things that it can do. And at some point, we need to go back and check off those things and see if they actually happen in your product. Now, to be honest, if you get like 2/3 of the way through the implementation and you're like, man, our class diagrams are really terrible and they make it really hard to work, we would rather have a working product than you try to like make this terrible design work, right? So you learn from it maybe and you move on. But there needs to be a reasonable effort here to kind of specify what the plan is for this project. So let's do next week, and then you have a week and a half, which is not that much time. So when you add your own features, try not to be too grandiose with your plan. And we're going to present in lab, so basically all the lab sections we're going to fill in and fill all morning. You should, again, in your Gantt chart, starting from here to here, have some activity that happens, for example, here, right? That makes some progress. It's important to make some progress before here. Because this team stuff is hard, and if you're all trying to power through at the same time here, then it's really difficult to get all those different changes, merged together and things like that. So you're definitely going to want to make sure there's some sort of steady progress going on. Also, in a team of 5 or 6, you can make subtasks, right? So, for example, I'm going to make you research some live sequence library to export animated GIF files. And not everyone needs to like hover over your shoulder watching that little piece of code get implemented into your project. Send 2 people off to go do that side project. And there's, think about how to divvy up the work into some chunks so you can kind of make some progress like that. Okay, questions? The hard part, in some ways, it's going to be important to make a team relatively quickly. I will check in on Tuesday on the teams, but you're really limited at that point in how much planning you're going to get done before it's due, right? So if there's no questions, I'll leave you to start going around here and breaking into teams. Get a start on it. And if you don't find a team, let's hit Piazza first, talk to me, see what can find other people. All right? So